Alright, so this is 13.8, the notes, and then you can put the homework on this same page. One thing you make sure that you have is this little handout that's on the front table by the chairs. All it has is just y equals a times sine b, and then parentheses theta minus h, parentheses plus k. And it explains what does a, b, h, and k mean, and then it gives you the steps for graphing. So a is the amplitude, we talked about that, that's just the height. B is the period, that's the length. H is the phase shift. So, and just make sure we flip that, right? That's the same kind of thing with absolute values or whatever. And then K is the vertical shift up and down. Steps for graphing. So determine the vertical shift and graph the midline. 2, determine the amplitude, graph dash lines for the max and midlines. 3, determine the period of the functions and graph that function. So they be kind of a dash line or a different colored pen or pencil. Maybe darker, lighter, whatever, dashed. And then 4, determine the phase shift and translate the graph. So first things first, this example right here, we have y equals 2 sine theta plus 3. And then one thing I just didn't mention with this little part is that cosine could be in here instead of sine. It doesn't matter. Other than that, the graph will be a little bit different, but all the rules still apply. So we have y equals 2 sine theta plus 3. So first thing that I want to do, and you're going to have to do this on any sort of assessment, but start labeling what you have. So your vertical shift, Vs, that's right here. Right, that's our plus k at the end. That's a positive 3. All right, my amplitude I'll need to know. That's this first part, right? So that's 2. So positive 2. My period, that would be this number that's here. There's not one that we can see, but it's just 1. So 360 divided by 1 is just 360 degrees. So we don't have to worry about scrunching anything up. And then you have, there you go, the phase shift, PS. And that says, is it moving left or right? That's what the phase shift is. Is it moving horizontally? And that is, no, there's no extra phase shift that we have to worry about. All right, so it's just about a vertical shift. So that first step, right, determine the vertical shift and graph the midline. We already said that the vertical shift was 3. So let's graph the midline. So that's just going to be up 3. So 1, 2, 3. So I'm just going to put a dash line there, right? Maybe, ML for midline. Right, this is basically my new x-axis. All right. Now number 2, determine the amplitude and graph the dash lines for max and min. My amplitude is 2, so from the midline I'm going to go up 2. Just make some little couple dashes there so I know that's as far up as my graph will go, and then down 2 from the midline. That's as far down as it will go. So your graph should never get out of from between these two lines right here. All right. Now we have determine the period of the function. We already talked about that's 360 degrees. Nothing changes. So we don't have to, basically there's not going to be like a dash line graph because nothing has changed for the phase shift or anything like that, or the period. So we won't have to worry about that. Let's just graph what we have now. All right, so sine, we've talked about how sine at 0 degrees, it just starts right at, usually at the origin, but we had that vertical shift, so it's right at 0, 3. All right. Then at 90, right, it's at its top, its peak. So at 90, it's at 5, so 95. That would be the actual coordinate there. And then 180 is back to the midline. 270, it's down to the midline. 360, it's back to the midline. Now we can go the other way. So we got at negative 90, it's at the bottom, the midline. Then 180, it's at the midline. Negative 270, it's at the max line. Then back to the midline for negative 360. And now we can just connect the dots. And look at that. All right. So now what kind of changed from what we did on Friday is just a matter that for this one, it was just a vertical shift. The graph shifted up a little bit, and that's where it's oscillating now, right, where it's revolving around. Cool? All right. Second example then, a little bit more difficult. We have y equals 4 cosine, and then we have theta minus 90 degrees, minus 1. That's a negative 1 right here. All right? So we got a lot more going on this time. Again, same steps from the beginning. What is my vertical shift? Well, it's minus 1. That's right here. This is that plus k. It's negative. So my vertical shift is negative 1. What is my amplitude? That's right, this first number, that's 4. Again, our period, there should be a number here if it's going to change. It's not just 360 divided by 1, so it's just 360 degrees. And then our phase shift this time, we do have, it's right here. Now it says theta minus 90 degrees because it's h in our directions. Make sure we flip, okay? So instead of being negative 90 degrees, it's a positive 90 degrees. We're going to go to the right 90 degrees. All right? So first things first, again, let's graph the midline. It's at negative 1. So I like making a little dash line so I know where is the midline. That. So there's my midline. Next, let's find the max and midlines. Right, use the amplitude, so it's 4 up. So 1, 2, 3, 4. So that's the max my graph will go. And then 1, 2, 3, 4. Here's the min that my graph will go, the minimum amount. Again, these are kind of the boundaries for the graph then. All right, so you have that. Our period is still 360 degrees, so it's not going to scrunch up or get any wider. And now we should just graph, before we do the phase shift, let's just graph to see what it is, and then we're going to shift it left or right, in this case, right. All right, so we're going to first graph it, we're going to graph a different color, or this is where you're going to use a dashed line. So cosine right off the bat, right on the y-axis, it starts at the peak, it starts at the top part. For us, that's at 0 degrees 3, so it starts right there. Then at 90 degrees, this is where our graph is hitting the midline. So remember, our midline is at negative 1, not here. So there's our midline. At 180, it's now at negative 5. At 270, it's back at the midline. And at 360, it's back to the max line. We're going to do the same thing now going the other way. So negative 90, it hits the midline. Negative 180, it's in the minimum value. 270, it's back to the midline. Again, our midline is negative 1. And then at negative 360, it's back to our max line. Okay? So we're going to make a dash look of the graph. Like that. So now we have the dash line. Now this is basically, that's what part 3 is, right? With the period or with the phase. Before the phase shift, this is what you should have. Now we're going to do step 4, and we're going to shift all of our points. So you can start from left to right or whatever you want to do. But our phase shift is plus 90 degrees. We're going to go 90 degrees to the right. I'm just going to start the y-axis. So here's the point. I'm just going to move it over 90 degrees. Here's the point, move it over 90 degrees. Here's the point, move it over 90 degrees. Here's the point, oh, it's off the graph, whatever. Okay? Then we go on the left side. Here's the point, we move it over 90 degrees. Here's the point, move it over to 90 degrees. Here's the point, move it over 90 degrees. And here's the point, move it over 90 degrees. And then we can create that last point because you know it's going back down to the midline. All right? Once you have all the points on, now you're going to use either a different pen or you're going to use a solid line. And then this is kind of going off. Oh, right there. Actually, this point, there's a point right there. There you go. Just like that then. All right, so this is the final graph. All right, is that solid one? It's the after phase shift. So if you have a phase shift, you have to make sure you let me know that which one is the final one, especially if you forget to dash one of them or whatever. So make sure you do tell me which one is the final graph. All right. Then for homework problems, there we go. I'll write those right here on for you. So number 14 is y equals cosine theta plus 180 degrees. So the only thing that's changing is you do have a phase shift. That's the only thing that's going to change, is that you have a phase shift from the parent graph. We have number 20, which is y equals cosine theta plus 3. Right, notice all we have is a vertical shift then. All right, and again, you do need to write out what's my vertical shift, what's my amplitude, what's my period, what is my phase shift every single time, whether you have it or not. 23. So 23, y equals 2 cosine theta minus 5. So this has got kind of a good amount going on. 24, we have y equals 2 sine theta minus 4. Then we have 26, y equals 4 sine theta minus 60 degrees minus 1. All right, and again, remember, on the x-axis, each one of these little grid marks is 30 degrees, so that shouldn't be too much of an issue. And then 27, y equals cosine 1/2 theta minus 90 degrees plus 2. I'm going to change this to just cosine 2 actually. All right, so I want this one to be cosine 2 and then theta minus 90 degrees. So this is going to be the first one, the only one in your homework, that your period is 360 divided by 2, which is 180 degrees. All right, so that cycle is going to shift down. Not shift down, but it's going to get smaller. The length is getting smaller. It's not going to be 360 degrees. It's going to be 180. All right, so that's going to be kind of one of the more special ones. 26 is a good one that we need to get down and know very well. 23 and 24 are kind of a lot like the examples I've given you. All right, so this is for Monday's stuff. Tuesday, we'll see how that goes, or else you might have a couple extra problems for the board. All right.